Okay, so these last two examples, the best idea in a case like this or like this, if this equals 0, a lot of the time when you have lots of things going on, the best thing that you can do is try to factor something and then set each of the factors equal to 0, and then you can get your answers by looking at your unit circle. So when I start with this one, the first thing I would do, it's really, really tempting to divide both sides by sign and cancel them out. Get 1. The problem with that is then you wouldn't have, there's one solution that's missing if you do that. So I'll show you what I mean by that. Okay, so let's not do that. Instead, let's get it equal to 0 so we can factor. So I'm going to subtract sine from both sides. So sine tangent minus sine equals 0. And then I'm going to factor out a sine. So that's just my greatest common factor. So if I take a sine out of here, I get tangent on that term minus 1 on that term. Then I can say, okay, now I'm going to set my sine of theta equal to 0 and my tangent of theta minus 1 equal to 0. So each of these factors equal to 0. Then I can find the solutions for those. This one, I'm going to go ahead and add 1 over here. So that means I'm looking for when tangent of theta equals 1. So first, let's look for when is sine of theta 0. So if I look at my unit circle again, remember sine is your y value, and I'm looking for when is that 0. So it's 0 right here at 0, and it's 0 right here at 180, or pi. So I'm going to just write those out. The other thing too, like if I keep going, so let's keep going around the circle. It's at 0, it's at pi, it's at 2 pi, it would be at 3 pi, and so on, right? So I'm going to list those out just kind of in that way. So this solution right here would be, it happened at 0, it happened at pi, it happened at 2 pi, and then I'm just going to put a dot, 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 because I know that keeps going. Okay, the other situation was my tangent. When is tangent equal to 1? So again, let's go back over here. Tangent, remember, is sine over cosine. So when would I get 1 if I take my sine and divide it by my cosine? That's going to happen when the two values are the same, including the sine. The signs have to be the same. So that happens at pi over 4. It does not happen here. A lot of people might get that one accidentally. So this one, pi over 4, and then it happens again down here at 5 pi over 4, right? And then it would happen again when it goes back up there and back down here. So if you look at that period, if we think about that as a period, it's going from pi over 4 to 5 pi over 4, which is a period of pi, okay? All right, so a pi over 4 and a 5 pi over 4 and a dot, dot, dot. One note that I made there is that the period would be pi. This one, so when you think about tangent, the period of tangent is pi. So that makes a lot of sense. This one is a little bit different because remember, it's the same as that cosine example we had a second ago where this is happening every pi value when the period of sine is actually 2 pi. So the period, though, in this instance is pi because that's happening every single time. Okay, so I need to write both of those in a general way. So my theta value could be pi times n, meaning if n was 0, it would be 0. If n was 1, it would be pi. If n was 2, it would be 2 pi, and so on, right? But if I was talking about negatives, so let's go backwards, it could also be negative pi or negative 2 pi, right? So if this was negative 1 or negative 2 or negative 3, that still works, okay? The other situation, if I write it generally, would be, in this case, my pi over 4 plus, remember, I could add, so I have two cases, and these are not necessarily, if I take pi over 4 and I add pi to it, I get 5 pi over 4. So these are not really, I don't have to write them separately. I'm trying to think of a good way to say that. I don't have to write it as pi over 4 plus pi n. and then 5 pi over 4 plus 5 pi n, because this already covers that value. So this is my general solution for that. So if they just said find all of the solutions and they wanted a general answer, this would be your two answers. Now, if they specifically say in the directions, which they do a lot in this lesson, a lot of their directions say, I just want it on this interval, okay? If that's the case, I would just give them everything in this interval that happens here, right? So definitely 0 happens there. And then if you want to do all of these, that's fine. I'm going to go in order. So if I'm starting here at 0, the next one that worked in this case was pi over 4. Okay, so I'm going to throw that one in there, my pi over 4. That was over here in this case. And then my next one would be pi, because 5 pi over 4 is down further. So here's my pi, here's my 5 pi over 4. So pi is an option, 5 pi over 4 is an option. And then, okay, so from there, the next one would be 2 pi, right? But remember, this is an open parenthesis right here. So it really only goes up to that one. I don't have to put that last one of 2 pi because that's open. Okay, so in your book, in your homework, most of them are following this set right here, where you just give me everything that fits this scenario on the unit circle, right? Okay, example 5, this one's a little more complicated. So I've got something, it's kind of set up like a quadratic. I've got a sine squared, I've got a cosine, I've got something with no trig function on it. This would look a lot like a quadratic equation if this were also cosine, or if this were also sine. If I could switch one of these, then I'd have the same trig function and then none here. That would look like a quadratic, and then I could factor it. So that's what I'm hoping to have here. So I would replace this right here with, let's factor out the 2 first. So I'm completely ignoring this side. Let's just look at this side and say, I'm going to take a 2 out of that. And then I also know that sine squared is the same thing as 1 minus cosine squared. So that's one of those Pythagorean identities again. We use that a lot, so just get used to that. So if I rewrite that as this, then I could distribute that 2 back in there and simplify it, and I have what I was talking about, where I have a cosine squared and then a cosine and then no cosines. That's a quadratic formula, kind of like an x squared, x, no x's. So let me write the rest of this in here, and then we can start simplifying. So this, if I distribute that, would give me 2 minus 2 cosine squared of t minus cosine of t minus 1 equals 0. So I'm going to put this and this together. So I have a negative 2 cosine squared minus a cosine. That would be plus 1. 2 minus 1 would be positive 1. So all that did was switch that sign right there. Then if I go to factor this now, so this is like me saying this is negative 2x squared minus x plus 1, right? So we've done that type of factoring before where you put it into 2 sets of parentheses. I would instead prefer to have this a positive 2. That leading coefficient is always bad if it's negative. It just makes things more complicated. So I would just switch all of my signs, kind of like you're multiplying everything by negative 1. So that makes that a positive 2 cosine squared, and then plus a cosine of t, and then minus a 1. So I'm kind of going back to where I was. And then this times a negative 1 would be 0 still. Okay, then I'm going to factor this. All right, so my first term right here is going to be, what can I multiply to get this? So I'm just going to separate up my cosines and put a 2 with one of them. So 2 times cosine times cosine. So 2 cosine times cosine is 2 cosine squared. Then factors of 1, 1 times 1. Since this was a negative, that tells me that one of these needs to be negative, one needs to be positive. And because the middle term is positive, that tells me my bigger one needs to be positive. So if I think about this term right here would be 2 cosine. This would be 1 cosine. So what I want is a positive cosine minus a cosine. So if I have 2 minus 1, I get 1. Okay, once I have that factored, then I can pull these down and set them equal to 0. So 2 cosine t minus 1 equals 0, and cosine of t plus 1 equals 0. So in this instance, I'm looking for 2 cosine of t equals 1, which is when the cosine of t equals 1/2. This one, I'm looking for when is the cosine of t -1, right? So now I'm going to look for those cases on my unit circle again. So I'm looking for when is cosine 1/2. So let's look for this one first. Cosine is 1/2. Remember, cosine is your x value. So right here at pi over 3. And then another cosine of 1/2 would happen all the way over here, 5 pi over 3. So I've got it at pi over 3 and at 5 pi over 3. Okay, that was the only 2 cases where it happened on that interval. This one didn't specifically say where does it happen on that interval, but your directions in your homework are going to say that, so I'm just going to stick with that. If they ask for, I'll show you the other one too, because what if they ask you for the general one? So I'll show you both, but this is if they give me those. The other situation would be cosine being -1. So cosine being -1, so cosine is your x value. Looking for -1 would happen right here at pi. That's the only case where that happens. So at pi is that case. All right, so let's think about that. If I'm not on the unit circle, so if they're saying on this interval from 0 to 2 pi, my answers are what I just gave. So I've got a pi over 3, I've got a pi, and I've got a 5 pi over 3. Those 3 situations there are done. And then, okay, if they asked you for the degrees also, let's do the degrees also just in case. So it was pi over 3, pi, and 5 pi over 3. So that would be 60 degrees, 180 degrees, and 300 degrees. So 60, 180, and 300. Okay, the general solution here. So let's think about this. When I go from pi over 3 to 5 pi over 3, that was the 2 cases where that happened. If those are on a consistent increment like pi or 2 pi, then I could make that actually an easier situation where I only write one expression for it, but these are not. If I add pi to this, I end up over here. If I add 2 pi to it, I would end up at the same spot again. So I need to just think about the general solution being my pi over 3 plus, in this case, cosine 2 pi would be my period. So 2 pi n. Another situation could be that 5 pi over 3, which is in a different spot. So 5 pi over 3 plus 2 pi n. Another situation would be the pi. So that one would be pi plus 2 pi n. And I think that is it for my general solution in radians. If they want the degrees, it would be this same situation except in degrees. So this would be 60 degrees plus 360 degrees times n. This one would be my 300 degrees plus my 360 degrees n. This one would be my 180 plus my 360 n. So again, it depends on how they're asking for it. I really feel like the majority of your homework is going to ask for this, but watch your directions. I think it starts out asking for these general solutions, and then later in the homework, it asks for these more specific just on that interval.